Hello dear students, I'm Dylan. I'm here for talking about a new section in the Calculus 1 chapter section 4 about our syllabus about the trigonometric function. In here, before we are starting, we need something about and really trigonometric function and its inverse. As I mentioned in 1.3, we have an inverse of the function. How about the inverse of the trigonometric function? When I say trigonometric, I mean sine of x, as we have here, sine, we have sin, like that. We have the sixth one, sine, cosine, tan, okay. Sine is equal to opposite over hypotenuse, and also we have a cosine adjacent over hypotenuse. Also tan is equal to opposite over adjacent, which means that is equal to sine over cosine. And we have a cosecant, maybe this one's for you new, and secant and cotan. Now I'm going to sine of x, cosine of x, okay, tan of x was equal to sine of x over cosine of x. You know that. Now number 4 is new for you. I say secant of x is equal to 1 over cosine of x. And number 5, cosecant is equal to 1 over sine of x. Number 6 is equal to cotan, which is equal to 1 over tan. Or you can also say cosine over sine. Maybe these one are new for you, but it's okay. It's not strange. Why? It's not difficult, because just mixing. We have two basic things, sine and cosine. Later we are mixing, dividing inverse, 1 over them, 1 over the other one. So secant related with the cosecant, cosecant related with the sine. That's all. Okay. So how about the angle? For example, if I say sine of any angle, for example, pi is equal to 0. Cosine of pi is equal to -1. Now find the tan. Tan is equal to what? Sine over cosine is equal to 0. How about if I say find cotan? Cotan is equal to cosine over sine with undefined. How about secant of x? I don't know. Secant of pi. I say I don't know. Secant is equal to 1 over cosine, which is equal to 1 over -1, which is equal to -1. How about if I say cosecant of pi? I don't know. Cosecant of pi is equal to 1 over sine of x, which is equal to 1 over 0, which is also undefined. That's all. Now, if you have, you have information about sine and cosine, the rest one are easy. Why? Because one more to the next are easier. Why? Because you know how to do it. Never mind, this is not very difficult for you, but I'm going to share with you this information as soon as, because you need really good background. And this is if there's an angle, any angle. For example, you have 45 is equal to pi over 4. Okay, if I say pi over 4 means that I'm going to start from here, from x-axis, as a counterclockwise. That's why I have a positive. If I say I'm going to there, this part, this means that negative. If I'm going with the direction of clockwise, it means that negative. Why? Like that, 1, 2, 3. Why? Because this is the negative angle. So that's why, for example, if this is 45, I say is equal to minus pi over 4 or minus 45. And sine here, all are positive. Here just sine is positive. Here just cosine, sorry, none of them are positive, none. Here, when I say none, I mean sine, cosine. Why? I am just talking about the sine and cosine. As I told you, there are these two are very basic, are fundamental of the other ones. That's why. So cosine is negative. Here sine negative, cosine negative. Here sine negative, cosine positive. In case you have these sine in other way, you can do it. You can do this. Okay, don't mention it. Don't follow my work. Follow my way. Just follow your way that you know how to do it. Maybe in the high school, you know, in the other side. So this is about page number 1. I'm going to the page number 2. Especially here, I'm going to give you an idea about here. Now here's all positive, sine positive, tan positive, cosine positive. It's tan positive means that both of them are negative. Why? Because if you divide this one, negative over negative, you get positive. And sine over cosine is equal to tan. That's why he say tan positive. Okay? As I told you, we have two-way to what? We have two-way to what do we say? To control the angles. How to control the angles? Which way we have? We have basic and big angles. Also, we have the first quadrant, çarek quadrant, first quadrant, second quadrant, third quadrant, fourth quadrant. So we have these all big basic angles, and we have the first quadrant basic, and the other ones are the repetition, are the reference of the first quadrant. Which I mean that here, if I have a circle, unit circle, if we are talking about x and y, this point is equal to what? Here's 0 over y, 1 over x. So I have 1, 0, right? How about here? Is equal to what? 1, 0 over x, right? I'm here 0. How many over y? 1. Because I have a unit circle. Unit means that the radius are equal to 1. The radius are equal to 1. How about here? If it's 0, this is minus 1. And how about the y-axis? There is no moving of the y. That's why I'm putting this point as a minus. How about here? Again, 0 minus 1. Okay. Do not forget we have xy, xy, xy. Okay, dear. Now, and you know, this is the, you can say this is a cosine, and this is the sine. Okay, do not forget, cosine is x-axis, sine is y-axis. And how about the angle? This angle is what? Now I am here, 0 angle, right? So I'm writing theta is equal to 0. Now I am moving to here, which is equal to what? 19, right? 90, sorry. 90 is equal to what? Pi over 2. Okay, the angle is pi over 2. Now I'm going to what? I'm going to here, which is equal to pi 180, which is equal to pi. Okay, again I'm going to here, which is equal to 270, and also you can say is equal to 3 pi over 2. Pi 1 pi over 2, pi 3 pi over 2, and 2 pi, you know, 360. Okay, dear. Okay, so what's the benefit of this circle? It's very, very important. You don't need a calculator. You don't need to memorize the angle. Why? Because when I say, give me sine of pi, now we are directly recognizing this point, and sine is what? Is y-axis. I told you, so is equal to 0. You don't need to memorize it. That's why I say I'm going to help you in such a tricky way. How about if I say cosine of pi? Look, I'm going to pi, which is minus 1 and 0. Cosine of pi is equal to what? Cosine's x-axis is equal to minus 1. That's all. I think it's easy, and I think you can control it. Now it's your turn. Try to find sine of, for example, pi over 2, cosine of pi over 2. Pi over 2 here, sine is here, so 1. Pi over 2 here, cosine is here, so 0. You don't need to memorize this one really. I don't know about the angle. If you are asking me, I say just give me 1 minute and I'm going to find for you. So this is about the angles. How about first quadrant angles? What we have, the first quadrant angles. We have 3 basic angles. Now you know here's 0. Theta is equal to 0. And you know theta is equal to pi over 2, right? So I'm going to talk about this area between here. The middle between 90 and here 45, right? So pi over 4, 45. And here we have what? We have pi over 6 is equal to 30. How about here? Now I'm going to here. Is equal to what? Is equal to pi over 3 is equal to 60. Okay, here's your angle, angle, and angle. Okay. Now tell me about the sine of here. Tell me about cosine of here. Tell me about tan of here. How can you find this one? It's not easy. You know about the 0 and pi over 2. Now I'm going to give you a table. We will arrange the angle from 0, okay, pi over 6. What else? Tell me. Pi over 4, thank you. What else? Pi over 3 as usual, and last one is pi over 2. Thank you very much. Now I'll give you this table. I'm writing sine and I'm going to write cosine here. Now you know how to do this one. You have a fraction. Can you do it? Fraction is easy. Cut. Okay. And also you know how to write 2, right? So put 2 in the denominator. Gera. Put the 2 in all the denominators here. Okay, thank you. Also please do like that. Square root. I think it's easy. Square root of any number. Now I think you know how to start with the 0, 1, 2, 3, 4. Please repeat this part of the movie or the video more and more. And also you know how to descend from 4, 3, 2, 1, 0. Now you know the angle, the value of sine and cosine of all these angles. How? And you know to do something here. 0 over 2 is equal to 0, right? Okay. 1 over 2 is also equal to 1 over 2. It's okay, it's okay. 4 is equal to 2 over 2 is equal to 1. Am I right? How about here? 0. How about here? 1 over 2. Forget. It's equal to 1. Okay. Let's just we do some basic things. If you don't need it, don't do it. Now, you tell me. It's your turn. Sine of pi over 6. Please do not use the calculator because in the exam, the calculator will be forbidden. It's not allowed. You cannot use it. So how we find, come on, how we find the pi over 6 is not easy. Yes, it's easy. If you have this table, sneeze with the other graph, with the other circle, you need just 1 minute for the example. So for the exam time. So please try to do it and follow this way. So sine of pi over 6 here is equal to 1 over 2 without using calculator. Now tell me about the cosine. Cosine of pi over 6. Now I say cosine pi over 6 is equal to that. Maybe I'm going to ask you about tan of pi over 4. I don't know really tan over pi over 4. Yes, you know. Because tan of pi over 4 is equal to sine pi over 4 cosine pi over 4, right? You know, tan is equal to sine over cosine. Okay. Here's pi over 4. How about cosine pi over 4? The same. And they are the same. So this one, that one, and that one is equal to 1 over 1 is equal to 1. That's all. I think it's easy, right? If you have this table, and if you draw it, if you do your table, and you find this very easy. So please try to use this one and deal with it, because calculator is not allowed. That's all. This is about all the positive, and here in the page number 2 I'm going to give you really more time about this one, and I'm going to show you this graph. Really, they are very important. Even in the limit we will use something like that, how we find this. So the graph here is really very important. So do not forget about when I say find the limit of the cosecant, you should know. For example, I say at the point pi, you should tell me it's going to infinity or negative infinity. So if you don't know how to sketch these graph, you cannot find the limit of the trigonometric functions. Okay, dear? That's all. And do not forget about even and odd function. We mentioned that one. We say cosine is even. So, and also we say sine is odd. So from this one, you know, because secant depends on the cosines, 1 over cosine, so it's also even. And because tan, we are dealing with the tan, and there's odd, so we'll get odd. So just these two are even, and the rest one are odd. Now it's time to sketching this graph for you. It's very important in the period from 0 to 2 pi. And later I am going to talk about identity. Okay. For this part, before we are going to the inverse, we have what? Sine of x means that y is equal to sine of x. You know we have a limit here. The range is between 1 and -1. So when I say sine, we are starting from here, like there, and go on. So here's pi, here's 2 pi, right? And here's pi over 2, and here's 3 pi over 2. So this is the function. I'm going to ask you, is 1-to-1? No. Is the function? Yes. So horizontal told me it's not 1-to-1, but the vertical told me this is the function, the graph. How about the second one? Y is equal to what? Y is equal to cosine of x, as you know, as usual. We have 1 minus 1. You already saw this graph, and we are going to start something like that. Here's, sorry, you shouldn't exit -1. Here's pi over 2, pi, and 2 pi, 3 pi over 2. Again, y is equal to tan of x. The volume, the picture is like that, and we have asymptote here, and asymptote there. In here we have no asymptote, در کنار, but here we have asymptote at pi, and also pi over 2, and also here we have a minus pi over 2, and again we have a repetition of this part, like x to power 3. We have 3 pi over 2, as you know, and here's also we have what? Here's 0, here's any number, pi. So here also minus pi, and the asymptote is minus 3 over 2. Now cotan, y is equal cotan of x. Also you have asymptote here, please, number 1, 2, 3, 4, go like that. Okay, so in that case we have second cotan, cotan is like tan, but we have two different things. We are starting here like that and like that. So the shape, this one, the face is to the y-axis, but here the back is with the y-axis, not the face. Here's the face. And the second difference is what? If you are compared with the tan, the second difference is we have pi as a asymptote. Here we have a pi over 2. So be careful from here. So 0 and pi are asymptote, but here minus pi over 2 and pi over 2 are asymptote. How about this next one like that, next one like that, and go on. Now the two new things for you, y is equal to secant of x. We have the graph is like that. The second, we have, careful here, 1 and minus 1 are asymptote, horizontal asymptote. Here you are going to there. And how about the vertical? The vertical here, so this point is what? 0 over y, x, and 1 over y. So this asymptote are what? Are pi over 2. Now how about here? The asymptotes are minus pi over 2. And go on. Repeat here. From here, you have 2u and another 2u at minus 1. And go on. Okay, dear? So last function is a cosecant of x. Really, we need these all examples, all functions to count what? To count or to find the inverse. Even though they are not one-to-one, but we will what? We will cut. We will cut the domain. We will cut the x-axis to get what? To get one-to-one, huh? Now I'm going later. I'll go to cut here. How about this one? I'm going to cut here. So I got what? I'll get negative. How about this one? If I will take this one, just one-to-one, right? Yes. But now it's not one-to-one. How about here? Now, yes. How about here? Okay. How about here? If we restrict, is one-to-one. The same thing true for cosecant as a function. We have what? We have here 1 and minus 1. Also we have here, and the asymptote is like a cosecant is pi. Here's pi over 2, pi over 2. Here's pi, pi. That's why I say please go on with it. So asymptote that can add pi over 2. Here is pi like cota. And again here also we have something like that. Okay, dear, and go on 2 pi, and you know the rest of that. In the page number 3, this part we have identities. So they are very important. Do not forget about and you know cosine plus sine square are equal to 1, and 1 plus tan is equal to secant. How I derive? I memorize all these rules. You don't memorize it. We have cosecant square of x plus sine square of x is equal to 1. And now try to divide this example. For example, we have cosine square of x plus sine 1 is equal to 1. How can I get the second one? Try to divide this one by cosecant square of x, cosecant square of x, cosecant square of x. Now cosecant over cosecant is equal to 1 plus sine square over cosine square, as I told you, tan square of x. Okay, 1 over cosine square is equal to secant square of x. So you don't need to memorize this one. Even I don't know it's equal to 1 or not. Now try to divide also this equation star by sine square of x, and you get this one. Okay, dear? How about this part? And you know how to additional cosine. So let's say start with a sine if it's a positive, sine a sine cosine b, cosine a sine b, and go on. You know, you saw this one. How about this? Also, they are very important. We have a single and double angle. So here's the double angle, and the other one's half angle. This one is very, very useful, especially in the integral in Cal 2. You need this rule, very, very important. You can see all these identity are really useful for the integration. That's all about, and forget about the law of cosine. This is the first part of the 1.4 with a trigonometric function. And now later in the second video, I'm going to talk about trigonometric functions inverse. Okay, we are going to talk about trigonometric functions inverse. So how we find, for example, cosine inverse of x is equal to what? How about the picture? How about the things? Also, before I am finishing this really this section, there's one more important things. I'm going to find the paper, and then later I'll say that. Let me see. Here's the graph. I want to find the graph really. Here's the graph. Okay, now it's your turn. Tell me about the domain of sine. Domain of the sine. I need it. Okay. Tell me how we find domain of sine. By which way? Can you tell me over the picture? Think about it. I'll be with you. Just think about it. Look, the domain, as I told you, is a whole shadow. So here's positive part, shadow of here, over x and positive. So it's a real number, minus infinity to infinity. How about the range? The range, as I told you, shadow over y axis. So the d of f, r of f is what? It's minus 1 to 1, closed. How about here? Again, the same, shadow is all over x-axis and minus 1 and 1. How about this one? The shadows start with a 0 without pi over 2. And again start with a 3 pi over 2. So it's not going to be n pi over 2. When I say n pi, means that n if it's 1, and if it's 3 to n plus 1. Means that odd. So 3, 5, and go on. Also minus plus, because you have minus pi over 2. So the domain is equal to r, all real number, without these numbers. For example, pi over 2, minus plus, 3 pi over 2, means that all real number without these, because they are asymptote. They are vertical asymptote. They are, how do you say, در کنار ستونی. Vertical asymptote. So that's why. How about quadrant? Tell me, how about the range? Range is infinity, okay, and minus infinity. Tell me here. Tell me about this quadrant. Quadrant domain, there is no 0. There's a asymptote, okay. After 0, go on pi. After pi, go on. So is equal to r without 0, minus plus pi, minus plus 2 pi, and go on. Which you can write n pi. Minus plus n pi, and n from 0, 1, 2, that's cool. How about the range? The range here is all r. So the range r of f, range of function, is equal to r, all real number. Or you can write minus infinity to infinity. How about here? The domain, we have a 0. Yes, there's a shadow. Just take out pi over 2 and go on. How about the range? Look. How about the range? The range will start from 1 to infinity. This part, there is no shadow. We are starting with the 1 and go on. How about here? From minus 1 and go to down. So union minus 1 to minus infinity. And I will leave this one for you as a homework. So that's all about the domain of the function and the range of the function. Okay, dear? But they are very important. And the next video, we are going to talk about the inverse of these functions. Have a nice time. See you in the same section, 1.4, but in the next video. Thank you very much.